Welcome, children, to the wonderful world of solving equations that have variables on both sides of the equals sign. So without further ado, let's look at the steps for solving such equations. And there are 4 of them. Number 1, simplify each side of the equation if necessary. So simplify each side, on each side individually, if necessary. That's usually going to be because there are like terms that need to be combined. So you might have a situation where there are like terms. You may have a situation where instead there are parentheses that you need to get rid of by using the distributive property. And other than that, I think that's it. Those are the 2 things that you would need to simplify if necessary. Once you've done that, you're going to eliminate the smaller value of the variable. Sometimes you'll do that by adding. Sometimes you'll do that by subtracting. So there's going to be variable on both sides. You're going to eliminate the smaller value of the variable. If it's negative, you're going to add it. If it's positive, you're going to subtract it from each side. Remember that you're still dealing with your properties of equality here. Third, you're going to solve as you would a multi-step equation. Once you get rid of the smaller value of your variable, you only have variable on one side of the equation. And then you'll be able to solve it the way that we've learned the rest of the ones we're solving, which, even if you're struggling, you're still doing a whole lot better now than you were like a week or 2 ago. Okay, so the final step is to check your solution by using the substitution property. So that's where you plug it back in. Now, we're not going to see any decimals here, but we are going to see some fractions. And remember that we can eliminate decimals and fractions by using multiplication. When you're talking about eliminating fractions, you want to multiply by the least common denominator. So I'll multiply by the LCD, the least common denominator of the denominators. And if you want to get rid of decimals, you multiply by a power of 10. So multiply by 10, 100, 1,000, whatever fits in the individual circumstance. And it has to do with decimal places. 1 decimal place, multiply by 10. 2 decimal places you want to get rid of, multiply by 100, and so on. And we can do examples for that as well. Let's try one. So for your first equation, you have 6x plus 15 equals 4x plus 7. You have 6x plus 15 equals 4x plus 7. And we're going to solve this using our properties of equality. And we're going to start, like it said, by simplifying on each side. Well, there's nothing for me to simplify here because 6x plus 15, these are not like terms. Please do not try to add those together. 6x's plus 15. So you have 6 unknowns, 6 of the same unknown, plus 15 more. That's like, you know you're going to get paid X dollars per hour for 6 hours, and then you have $15 already in your pocket. So you don't know how much you're going to have at the end until you know the number of hours. That's why you can't add these together. 6x plus 15 are not like terms. So I can't simplify here or here. So I'm jumping to step 2, and it says eliminate the smaller value of the variable. Well, the smaller value of my variable here, it's between 6x and 4x. 4x is the smaller one. If I want to eliminate a 4x, if I want to get rid of it, I have to subtract it, and you even it out by doing the same thing on the other side. What does that result in? Well, what's 6x minus 4x? Well, we get 2x. We haven't done anything with our plus 15 yet, so I bring it down, bring down my equals sign. 4x minus 4x cancels, and I get 7. And now I have a 2-step equation. So you can add or subtract the variables to both sides of an equation or from both sides of an equation, just like you do with the numeric terms, the constant terms. So you can add or subtract the variable terms just like you do with the constants. Let's finish it from there. We know at this point we want to get 2x by itself, so let's get rid of plus 15 by subtracting 15. That gives me 2x is equal to negative 8. And we know that we get rid of the 2 coefficient by dividing by 2. And x equals negative 4. Always go back and check. Go back to the original problem. Plug in the x on each side and make sure you get the same answer coming out. Negative 24 plus 15 is negative 9. Negative 16 plus 7 is also negative 9. I know I did it right because I checked my answer and I'm good. Let's try another one. Okay, this time we have 7d minus 5 equals negative 4d plus 11. This particular problem is not going to come out to a whole number, so we really do need to know what we're doing solving the equation. There is, again, nothing to simplify on each side because I can't combine these like terms or these. So we jump to step 2, and we're getting rid of eliminating the smaller value of our variable. Well, the smaller value of the variable here is negative 4d. How you get rid of a negative 4d? You add 4d. And if we do that on the right, we got to do it on the left. That leaves me with 11d minus 5 equals 11. So here's where I know I'm not coming out with a whole number, because it should be 11d equals a multiple of 11 to get a whole number. And that's not what I'm going to get here. So now I go about my process, solving my equation as just a multi-step equation. We're going to add 5 to each side. 11d equals 16. We divide both sides by 11. And d equals 16/11. 16/11, which is an ugly little situation for me to check, but I will continue and power on just for you. All right, let's do just the left side first. 7 times 16/11. Well, there's some shortcuts here, and there are some ways your calculator can help you a little bit. It doesn't have to be super difficult, and it doesn't mean I have to do it not on a calculator because there's a fraction involved. 7 times a fraction, so a whole number times a fraction is a whole number times the denominator. So 7 times 16 comes out to 112. So right now I have 112/11 minus 5. Well, I can make 5 into 55/11 because that's equal to 5, and it has the same denominator. When I subtract 112 minus 55, I get 57/11. So that better be what I get on the other side of the equation when I plug in my 16/11. So this time we have 4 times 16, so that's negative 64/11, plus 11 whole things, which is 121/11, and that does indeed give me 57/11 when I add them together. Now look at what I did. I'm not doing anything with a calculator. I'm also not doing the fractions in my head. Really, if you think about it, once you get your common denominator, this is all just adding integers. Negative 64 plus 121, and I'm not ashamed to admit that I picked up a calculator and did it that way. So you don't have to do all the math out literally on paper. You can use the calculator to help you with some shortcuts. It's not that the calculator just spits out correct answers. You still have to know what you're doing to get there. All right, let's try another one that's a little bit different. This time we do have simplifying to do on each side before we can solve it. So we do need to simplify on each side here before we can solve this problem. And we're going to start by simplifying using the distributive property. So I'm going to multiply through the 2 and the negative 2. And what does that give me? 2 times 4 gives me 8. Minus 2 times 2x gives me 4x. And that's equal to negative 2 times x gives me negative 2x. And negative 2 times plus 5 gives me a minus 10. A minus 10 there. Negative times positive is a negative. Good. So we have simplified on each side. There's nothing else we can do to simplify. Now we're going to solve. And the next step is eliminate the smaller value of the variable. Well, this time I have negative 4x. Remember, we see a minus as a negative. And negative 2x. Well, negative 4x is smaller than negative 2x. So add 4x to each side of this. That leaves me an 8 on the left. Negative 2 and positive 4 adds up to positive 2. And then positive 2x minus 10 on the right. So 8 equals 2x minus 10. And then continue to solve the way you know how to solve a multi-step equation. Reverse your addition or subtraction. And then reverse your multiplication or division. And in this case, x comes out equaling 9. Let's check our work by going back and using the substitution property to plug that in. 4 minus 2 times 9 is 4 minus 18, so that's going to be negative 14. And so the left-hand side of the equation, when we plug in our solution, we get negative 28. Now we go ahead and test the right-hand side of the equation. This one's a little easier because 9 plus 5 is 14, and negative 2 times 14 is negative 28. Since the two sides match, I know I got my answer right. Let's move on to another one. So this one's a little bit different. Don't automatically write down a 5 right here, guys. Think about your order of operations. Order of operations says we must distribute first. So that this is the simplifying on each side individually part. I have an 8. Minus 3 times a is minus 3a. Minus 3 times a minus 4 is a negative times a negative is a positive. 3 times 4 is 12. Now I have like terms to combine as well. 8 plus 12 is 20. So I have negative 3a plus 20, or you could have 20 minus 3a. They're both fine. We have now simplified the left-hand side. Nothing had to be simplified on the right because you just have 2a, and 2a can't be simplified. But at this point, we now want to continue on to step 2, smaller value of the variable, which is negative 3 or 2, it's negative 3. Add 3a to each side, leaving me with 20 equals 5a, and then when we divide, a equals 4. And then we go back and we plug in our solution. So I take my equation and I write it out. 8 minus 3 times, in parentheses, 4 minus 4. What does that equal? So 8 minus 3 times 0, which is 0. So 8 minus 0 is 8. On the right-hand side, it's just 2 times 4, which is 8. I know I did it right because my answer came out correctly. Uh-oh, fractions. Don't panic. Don't panic. No need to panic. Remember that we can get rid of the fractions here if we multiply by the LCD. And you want to use your fraction mental math here. So we're going to take every single one of these terms and we're going to multiply it by the least common denominator. Well, our three different denominators here, 3 different ones, are 2, 3, and 4. Our least common denominator is the least common multiple of 2, 3, and 4. We'll start with 4. 2 goes into 4, but 3 doesn't. So now 8. 2 goes into 8, but 3 doesn't. 12. 4 goes into 12. 2 goes into 12. 3 goes into 12. I found my least common denominator. And we're going to multiply everything by 12. So everything times 12. 2/3 times 12 is 2/3 of 12. 1/3 of 12 is 4. 2/3 of 12 is 8. 3/4 times 12 is 3/4 of 12. 1/4 of 12 is 3. 3 of those is 9. Another 3/4 of 12, so that's 9m. And then finally half of 12, which is 6. We're simplified. We didn't actually have to simplify that. I was just trying to make life easier and get rid of the fractions. If you don't want to deal with fractions, that's a great way to get rid of them. Now this is my equation. It still means the same thing because I used a property of equality and I multiplied everything by 12, which means I still have an equivalent equation. Smaller value of the variable here is going to be your 8m. So let's subtract 8m from each side. Negative 9, because it was a minus 9 before, negative 9 equals m plus 6. Finish off by subtracting 6. And you have your solution, negative 15. Now I did go back and actually check this. I'm going to pause it though and write it out for you so you can see it. Because it was not really involved so much as it just took a while and I don't want to make our video too long. As long as you understand that you're supposed to be checking every single solitary answer, you don't have to write this one out. Let me write it out for you. Whew, ugly fractions. These are equal, so I know I have it right. Negative 43/4 is what I got when I plugged in my negative 15 on the right. And negative 10 3/4 is what I got when I plugged in my negative 15 on the left. They are equivalent because if I take this one and I make it an improper fraction, 4 times 10 is 40, plus 3 is 43, and since it's negative 43/4. Okay, you only have one left, and it's the good old exception to the rule. All right, so the exception to the rule, it's the exception to step number 2, because in step number 2, that's where it says we deal with the smaller value of the variable. Okay, exception to step number 2. We cannot subtract 2f from each side because it will leave the right-hand side at 0, and that does not really help in my situation. Instead, what I should be doing here instead is actually subtracting the 12f, because I can't subtract the 2f, I gotta subtract one of them, subtract the 12f. So in reality, it doesn't matter which one you use, whether it's the larger or the smaller value, but if you use my method, you will have to worry about negatives less often and have less trouble dealing with them. So when I subtract 12f from each side, I end up with negative 4 equals negative 10f. We divide both sides by negative 10. Remember, it's not about what's on the right, it's about what the coefficient is. The number multiplying the variable, that coefficient. That's what we're dividing off. This is positive 4/10, and I'm going to leave it 0.4 for the ease of checking instead of having a fraction. and we're going to go through and we're going to check our work here. So I go back to my original equation. I plug in the number I got for f, and I do the math. 4/10 times 12 is going to be 4 8/10. Minus 4 is 8/10. And on the right-hand side, it's 2 times f. So 2 times 0.4, 0.8. They are equal. I know I got it right. So we solve the equation, we check the equation, and we're done with the process. So I expect to see you bringing your questions in that you don't understand. I want to see some good IXL time accruing on these concepts, and hopefully you guys are comfortable and get it happily, and I will see you in class.